Okay, this is for Anatomy and Physiology 1. This is part 1 of Chapter 22, the lymphatic system and immunity. Okay, so the lymphatic system is a system of vessels that transports a clear fluid called lymph throughout the body. Now, lymph is similar to the circulatory system in that it's essentially circulates throughout the body. You have these lymphatic vessels throughout your body. It's a little bit different, and we'll talk about the differences, but it brings that lymph or carries that lymph throughout the body. Within that lymph, you have immune system cells that carry out an immune response. So that's why they're tied together, the lymphatic system and the immune system. So the major functions or the purposes of the lymphatic system is to drain the interstitial fluid. Remember, interstitial fluid is the fluid that it can accumulate in between the cells of the body. You don't want excess fluid in that location, in those locations, or else it's going to cause edema or swelling, so they drain it. They pull it out and they recirculate the fluid essentially. Another purpose is they transport dietary lipids, so lipids, fats from our diet that are absorbed in the GI tract, the intestines, back into the blood. They take them and they transport them. And they also facilitate, like I said, immune responses to protect our body from foreign invaders. So there is anatomical structures that accompany the lymphatic system. They are composed of the capillaries, lymphatic capillaries specifically, lymphatic vessels, the lymph nodes, lymphatic trunks, lymphatic ducts. We'll talk about the pathway of lymph flowing through these first 5 here. And then also there are what are called primary lymphatic organs and secondary lymphatic organs or tissues. So again, lymph is a fluid. It's clear to milky, and what it is it's interstitial fluid that's unaltered that enters the lymphatic vessel. So when that fluid goes from outside the cells into the lymphatic vessel, it is now called lymph fluid. And specifically in the GI tract, the fluid around that area has also lipids. So this is what a lymph node looks like. And you can see some lymphatic vessels on this side and down here. So the lymph fluid has a specific flow, okay? Generally it flows from the periphery towards central vascular. So it picks up fluid in the periphery and brings it towards the center vascular, the center parts of the body. The fluid, before it gets in the lymph, it starts out as interstitial fluid, as it says here. Once it enters the lymphatic capillaries, it's called lymph. And it's going to travel then via those lymphatic capillaries, vessels, to and past lymph nodes, which do the work. One of the organs that does the work in the lymphatic system. So it's flowing. The lymph fluid is now in the vessels, and it's flowing towards the center. So eventually, you can see in green here, in your book depicts the lymphatic system, the vessels as green. It either comes from the top side or from descending up. You can see this is the left subclavian vein, the jugulars that eventually will lead into the superior vena cava back to the heart. So the vessels will eventually either drain into what's known as the right lymphatic duct or the thoracic duct right here. This duct or that one, those 2 arrows right here. 1, 2. And eventually, like I said, then they dump it into the bloodstream. So let's talk about the smallest lymph vessels. These are called lymphatic capillaries. They're just a little bit larger than blood capillaries. And here is how they're unique comparatively. The fluid within them flows in one direction. Fluid can't go in and out. It can only go in to the lymphatic vessel because of the what are these endothelial cells that overlap each other. So this is a image. The yellow represents cells of the body, the interstitial cells and the fluid within it, and the black arrows represent the fluid going from the interstitial space into the lymphatic capillary. Notice how fluid is only going in, it's not going in and out, because when it gets in, it essentially, this is like a little trap door and it can't get out. Then capillaries unite to form vessels, which are similar to a vein. They have more valves actually than veins, and they have thinner walls. And the vessels eventually lead the lymph fluid past lymph nodes, past and through. And the lymph nodes are in many different parts of your body, and they contain masses, large amounts of B and T cells, the lymphocytes, and they function to filter that lymph fluid. And here's just an image of that all coming together, the different capillaries going up here from the side, from the left and right arm, and from the neck down. Eventually, those capillaries converge to vessels, to one of 5 trunks. Here you can see a mediastinal trunk. And then those 5 trunks empty into 2 ducts, either the right subclavian or right lymphatic duct or the thoracic duct. The reason why fluid goes from the interstitial space into the lymphatic vessel has to do with pressure differences, the milking action of when the muscles contract pushes it in, and also the respiratory movements as there's a pressure change due to the diaphragm contracting or relaxing. And this is exactly kind of the same reason why veins push blood up towards the heart. For some reason, there's an obstruction in the lymphatic vessels or some kind of malfunction. They're not going to do their job to bring that excess fluid in. So if they're not doing their job, excess fluid is going to accumulate in the tissues. You can see it here. It's called edema, where fluid accumulates in the interstitial spaces of the body. A lot of times, women, after they have a mastectomy in which their breast tissue is removed, when they take that breast tissue out, they also get some lymphatic vessels, and the swelling or edema can be a result of that. So that fluid has to be redistributed. All right, so those are the vessels. Now let's talk about the organs of the lymphatic system. It can be divided into primary and secondary. Primary, this is the bone marrow or the thymus. Those are the 2 primary lymph organs. And they're primary because this is where the stem cells divide and become immunocompetent, or essentially they learn how to defend the body. They become mature and able to defend the body of foreign invaders, to mount an immune response. The other organs where most other immune responses do the work, or where the work occurs, the spleen, the lymph nodes, and other lymphoid tissues such as the tonsils, for example. You actually have 3 sets of tonsils. We'll talk about later. So here in the blue just kind of points out some of those. The thymus is right on top of the heart. And we can see the red bone marrow. That's the primary lymph organ. Secondary, spleen, lymph nodes are spread throughout the body. And the tonsils, of course, are up in the head. The thymus has an outer and inner area. The outer cortex is just the outside of that actual organ. And this is where immature T cells reside. And the T cells, the immature T cells, actually come from the red bone marrow. They go to the thymus, starting with a T, to mature there. So T cells, think thymus. In the middle of that thymus, the inner medulla, that's where the mature T cells hang out. I already mentioned that right there. Here's a picture of the thymus. Here's the heart and the pericardial sac, and the thymus sits right on top of it. It is palpable, meaning you can actually feel it from the outside in infants. It's about 70 grams, which is pretty hefty. And at puberty, it atrophies, meaning it shrinks. And by the time you're older, it's scarcely even distinguishable compared to fatty tissue around it. This is because the T cell production is more active when you're younger. There are over 600 lymph nodes in your body, and they're scattered throughout in between lymphatic vessels. They are deep and they are superficial. And what happens is the lymph fluid comes in here and through the lymph nodes, and it filters possible pathogens, traps, destroys them. So you know when the doctors maybe you're sick like I sound right now, very congested. But if you have a sore throat and you go to the physician, they might palpate your cervical region and ask if it hurts, because you have regional lymph nodes called the cervical lymph nodes that if they're working or trapping and destroying a lot of foreign objects, they're going to be larger, okay, maybe even painful. If you have a clogged lymph vessel in here, they can even become hard sometimes. Axillary lymph nodes, that's in your armpit region, and inguinal, groin region, important ones to mention. Specialized, essentially, lymph nodes are called Peyer's patches that are actually in the intestines. So talking about the flow of lymph fluid again, through the lymph node specifically. The lymph fluid that is brought to the lymph node is brought in something called afferent vessels. Afferent vessels brings that fluid to the lymph node. And eventually it's going to direct it to this central area called the medullary sinus, so this area. And it has to go in and around all these little compartments. And in these compartments we find B cells, plasma cells, macrophages, T cells, okay? Dendritic cells, and they're going to become activated and spread the message of possible foreign invaders that might appear in that lymph node. And then if they do become activated, or when they do, they leave through the efferent vessels right here. So lymph leaves here along with antibodies that are activated, and activated T cells, which are fighter cells, and this area of the lymph node is called the hilum. Page 882 in your book also has some good information, more detail about that, so read on that. Another major organ is called the spleen. It's actually the largest mass of lymphatic tissue in the body. It's near the stomach, and it consists of a red and white pulp. The white pulp contains the lymphocytes, so the B cells and the T cells, and the macrophages that actually carry out that immune function. They do the job. The red pulp is red because it's blood-filled sinuses. This is where platelets are stored, and old red blood cells that are destroyed or being filtered. And that is the end of the part one, the anatomy essentially of the lymphatic system.